Tuberculosis, or TB, has plagued humanity for centuries. This ancient disease has left an indelible mark on our history, shaping societies and influencing the course of human development. Evidence suggests it has been around for millions of years, leaving its mark on human history. Fossil records and ancient human remains show signs of TB, indicating that our ancestors battled this disease long before modern medicine. This disease, caused by the bacterium Mycobacterium tuberculosis, has been a silent killer, claiming countless lives throughout history. The bacterium's resilience and ability to lie dormant for years make it a particularly insidious threat. In the 19th century, TB reached its peak, becoming a leading cause of death worldwide. The rapid urbanization and industrialization of this era created perfect conditions for the disease to spread, with crowded living conditions and poor sanitation. 1 in 4 deaths in Britain in 1815 was attributed to TB, demonstrating its devastating impact. The disease did not discriminate, affecting people of all ages and social classes, though the poor were particularly vulnerable. The impact of TB extends far beyond individual lives. Families were torn apart and communities were left to cope with the loss of loved ones. The social fabric of entire towns and cities was altered by the relentless march of the disease. It has shaped societies, influenced cultural practices, and hindered economic development. In many cultures, TB was seen as a curse or a punishment, leading to stigmatization and isolation of those affected. The fear and stigma associated with TB led to social isolation and discrimination against those affected. Sanatoriums and isolation wards became common, as people with TB were often separated from society in an attempt to control the spread of the disease. The disease's prevalence in overcrowded urban centers during the Industrial Revolution highlighted the link between poverty, living conditions, and health. Poor ventilation, inadequate nutrition, and harsh working conditions exacerbated the spread of TB. Despite significant progress in combating TB, its legacy continues to haunt us. Modern medicine has developed effective treatments, but the disease remains a major public health challenge, particularly in developing countries. The World Health Organization estimates that over 2 billion people are infected with TB, with a significant number developing active disease. Globalization and increased travel have made it easier for TB to spread across borders, complicating efforts to control it. The fight against TB is far from over, and understanding its history is crucial for effectively addressing the challenges it poses today. Public health initiatives and international cooperation are essential in the ongoing battle against this ancient foe. Throughout history, TB has been known by various names, including consumption and the White Plague, reflecting its debilitating nature and high mortality rates. These names evoke the fear and suffering that TB has caused over the centuries. It wasn't until the late 19th century that the bacterium responsible for TB was identified, paving the way for a deeper understanding of the disease and the development of potential treatments. This discovery marked a turning point in the fight against TB, offering hope for a future free from its grasp. Tuberculosis is caused by the bacterium Mycobacterium tuberculosis, a tiny organism that primarily infects the lungs. This bacterium is highly specialized and has evolved over centuries to become a formidable pathogen. While it primarily targets the lungs, it can also affect other parts of the body, such as the kidneys, spine, and brain, making it a versatile and dangerous adversary. This bacterium has a unique characteristic, a waxy outer coat that makes it resistant to destruction by the body's immune system. This waxy coat is composed of complex lipids and mycolic acids, which provide a robust defense mechanism. This resilience allows TB to survive within the body for extended periods, often without causing any noticeable symptoms. This ability to remain dormant is one of the reasons TB is so difficult to eradicate. Infection typically occurs when a person inhales tiny droplets containing TB bacteria, released into the air when an infected person coughs or sneezes. These droplets are microscopic and can easily be inhaled without the person even realizing it. These droplets can remain suspended in the air for hours, increasing the risk of infection in crowded and poorly ventilated spaces. This is why TB is more prevalent in areas with high population density and poor living conditions. Once inhaled, the TB bacteria reach the lungs, where they encounter the body's first line of defense, macrophages, specialized cells that engulf and destroy foreign invaders. However, the battle is far from over. The waxy coat of Mycobacterium tuberculosis protects it from being destroyed by the macrophages. This allows the bacteria to survive and even thrive within these immune cells. Instead of being eliminated, the bacteria can survive and multiply within these immune cells, establishing a foothold within the body. This is the beginning of a latent TB infection. This initial infection is often silent, with no symptoms or only mild ones that may go unnoticed. People with latent TB infection do not feel sick and cannot spread the bacteria to others. In this latent stage, the infection can persist for years, even decades, without causing any harm. However, the bacteria remain alive and can become active later. However, in some individuals, the infection can progress to active TB disease. This transition can be triggered by factors that weaken the immune system, such as malnutrition, HIV infection, or other illnesses. This occurs when the body's immune system weakens, allowing the bacteria to multiply rapidly and spread to other parts of the lungs or even other organs. The bacteria can cause significant damage as they spread. Active TB disease is characterized by a range of symptoms, including persistent cough, fever, night sweats, weight loss, and fatigue. These symptoms can be severe and debilitating, significantly impacting the quality of life. Tuberculosis is primarily an airborne disease, meaning it spreads through the air when an infected person coughs, sneezes, speaks, or even sings. These actions expel tiny droplets of saliva or mucus containing the TB bacteria, which can then be inhaled by others, leading to infection. The risk of transmission is highest in enclosed, poorly ventilated spaces, where these droplets can linger in the air for extended periods. Factors that increase the likelihood of TB transmission include proximity to an infected person. Spending prolonged periods in close contact with someone who has active TB significantly increases the risk of infection. Crowded living conditions, overcrowding, often seen in densely populated areas or shared housing, facilitates the spread of TB droplets. Poor ventilation, inadequate airflow allows TB bacteria to accumulate in enclosed spaces, increasing the likelihood of inhalation. Weakened immune system. Individuals with compromised immune systems, such as those with HIV, AIDS, malnutrition, or undergoing chemotherapy, are more susceptible to TB infection. It's important to note that not everyone infected with TB bacteria will develop active disease. In fact, most people with latent TB infection never experience symptoms or become contagious. However, they remain at risk of developing active TB later in life, especially if their immune system weakens over time. When TB bacteria enter the lungs, the body's immune system mounts a complex defense mechanism. This initial response is crucial in determining whether the infection will be contained or progress to active disease. The immune system's first line of defense includes various cells and proteins that recognize and attack foreign invaders. Specialized cells called macrophages engulf the bacteria in an attempt to destroy them. These macrophages are part of the body's innate immune system, which acts quickly to fight off infections. They patrol the lungs, seeking out and ingesting harmful pathogens. However, the waxy coat of Mycobacterium tuberculosis makes it resistant to the macrophage's usual killing mechanisms. This waxy coat is composed of complex lipids that protect the bacteria from being broken down by the enzymes within the macrophages. Instead of being eliminated, the bacteria can survive and even multiply within the macrophages. This ability to persist within immune cells allows the bacteria to evade the body's defenses and establish a foothold in the lungs. This triggers a cascade of immune responses, including the release of chemical signals that attract more immune cells to the site of infection. These signals, known as cytokines, help coordinate the body's defense efforts by recruiting additional immune cells to the infected area. The body attempts to contain the bacteria by forming granulomas, small clusters of immune cells that wall off the infected area. Granulomas serve as a physical barrier, preventing the bacteria from spreading to other parts of the lungs or the body. These granulomas can be effective in controlling the infection, preventing the bacteria from spreading further. In many cases, the bacteria remain dormant within the granulomas, causing no symptoms and posing no immediate threat to the host. However, they can also cause damage to surrounding lung tissue. The immune response that forms granulomas can lead to inflammation and scarring, which may impair lung function over time. In some cases, the granulomas may break open, releasing the bacteria into the bloodstream or other parts of the lungs, leading to more severe forms of TB. This can result in widespread infection and more serious health complications. The outcome of this battle between the immune system and TB bacteria depends on various factors, including the strength of the individual's immune response, the number of bacteria inhaled, and the overall health of the individual. A robust immune system can often keep the infection in check, while a weakened immune system may struggle to contain the bacteria. Factors like malnutrition, HIV infection, and diabetes can weaken the immune system, increasing the risk of developing active TB disease. These conditions compromise the body's ability to mount an effective defense, making it easier for the bacteria to spread and cause illness. If you enjoyed this video, we warmly invite you to like, subscribe, and leave a comment below. Your support means the world to us and helps us create more content like this. Thank you for watching.